Thank you, Fabrizio. Let me see if I can do this correctly. There we go. Can you see it? And can you hear me? Fabrizio, can I have feedback? Is okay?
Yes, we can hear you.
Okay, excellent. Fine. So, yeah, I will tell you a little bit about my experience in public flight in zero G, not only zero G, but also, as the title suggests, is Gateway to Space, Moon, and Mars. But first, I would like to thank all the organizer and also to thank them for the challenge they put me forward, because talking after Joe Vernikos, who had such a great talk and such an inspiring talk, it's really a great challenge, but I will try to live up to it. So just to let you know that we don't need to go to space to actually experience zero gravity, zero G. You can do that by simply falling free fall, the free fall, which is the unobstructed motion due and caused only to gravity. So if you are jumping from, let's say, two steps in the stairs, you're jumping down. Well, for this fraction of a second, you will be in zero G. This is what we do also with this kind of aircraft. This is the zero G aircraft that we use in Europe, that ESA, CNES, and the German Space Agency are using in Europe. You see the two other aircraft that are used on Earth to do public flight, the Zero G Corporation Boeing 727 that you see there on top, and in Russia, the Ilyushin EL-76 MDK that are used also for public flight. Now, how do we get into zero G? Well, you see the zero G aircraft, so on the left part, which is now in a...
You are not sharing your screen.
Yeah, we don't see your slides yet.
You have to share your screen.
I think I've shared it. Okay, let me just go back. Sorry. I have to get out of here. Come here. I think I shared. Oh, sorry. I didn't. Okay. And show you. There we go. Okay. Is that okay?
Yes. Now it's okay.
Okay, excellent. Sorry about that. Okay. So as I said, this is the aircraft that is used in Europe, and the two other aircraft on the top part, the Zero G aircraft from Zero G Corporation, and the lower part, the Russian Ilyushin that is used in Russia. How do we get into Zero G with an aircraft? Well, you see the aircraft Zero G there on the upper part to the left, which is a very delicate situation. It's in a phase, at the end of a phase called the pull-up, where the pilot actually pull on the stick, on the control, to bring the plane going upward, accelerating upward, up to an angle of 45 to 50 degrees. It actually is following this profile, this parabolic profile, from horizontal flight at the flight level 200, so that's about 6,700 meters. It would accelerate upward, put the full thrust to the engine, and at the same time pull on the stick, pull on the command. This is the pull-up phase that lasts 20 seconds. When the angle of climbing arrives here at 50 degrees, so at an altitude of 8,300 meters more or less, the pilot suddenly switch off the engine, so there's no force acting on the aircraft anymore, no force other than gravity that acts on the aircraft. The only force that acts on the aircraft is gravity. Due to its initial velocity, the plane would continue to climb. It would be immediately in a free fall, even during the climbing phase, reach a maximum of altitude, which is about 9,300 meters, and continue to fall freely, but this time diving downward. When the diving angle reaches 42 degrees, again, the pilot then will put full thrust back to the engine to accelerate and come back to an horizontal flight for the last phase, which is called the pull-out, for 20 seconds. So we have three phases in this parabolic maneuver: the pull-up, which lasts 20 seconds, for an acceleration a bit less than 2g, so twice the normal gravity you feel on Earth. Then the zero-g phase, the microgravity phase, during the free fall phase, what is called the ballistic free fall. There's no force other than gravity acting on the plane. The plane is directly free falling, even if it's going up first and then going down after that. That lasts for 20 seconds, 22 seconds. There's a couple of seconds transition before and a bit after. And then the last phase, which is the pull out, when you come out of this falling, where the acceleration gravity that you sense is again about 1.8 G for lasting for 20 seconds. And then we start again. And the little video here will tell you a little bit more about it.
So now we are on board this aircraft, the Airbus A300-0G, on board which we can really recreate zero gravity conditions, so the weightlessness state. And to achieve this, the pilot on board this plane will, from an horizontal flight, raise the nose of the aircraft up to an angle 40 degrees, same time putting full thrust to the engine, so accelerating up to 2G. After about 20 seconds, when the up angle is about 45 to 47 degrees, the pilot strongly reduces all engine thrust, only keeping enough thrust to counterbalance the air drag. At that moment, the plane is in free fall state, that is, the sum of all forces other than gravity acting on the plane is nil. The plane, due to its initial velocity, continues to climb, reach the maximum of the trajectory, and then start to dive down on the other side. When the diving angle reached 42 degrees, the pilot again pull full thrust of all the engine and accelerate for another period of 20 seconds, coming out of this dive and coming back to a normal horizontal flight. Now we are in the beginning of the pull-up phase, so the very first phase, where gradually the weight increased. Now my weight is increasing, is double. So now I'm about 150, 160 kilo. Of course, it's a little bit heavy to withstand, but you can see my face is now getting a little bit paler because all the blood is actually pulled down. The pilot announced the angle, the climbing out, 20, 30, and now we come to the injection point where all the engines are strongly reduced. You can hear also the noise is slightly reduced, and we start to float. And if I let the plane float, it will float freely in front of me, and you can climb up to the ceiling like that, perfectly in 0G. Now the diving angle are announced 20, 30, and it's about time to come back on your feet for the pull-out, which is the other part, the other phase of 2G, when the pilot accelerates to come back eventually, ooh, this is getting heavy, to come back eventually to a 1G flight. Wow. And again, during this pull-out, acceleration can reach up to 1.8 to 2G, and our normal weight is then doubled with respect to the apparent weight on Earth. Here we are back on an horizontal flight, ready for the next parabola, which will take place in about 2 minutes. So we repeat this sequence of parabola to reach a maximum of 30 parabola in total. And during these 30 parabola, we have up to 10 minutes of microgravity. We perform 3 flights within the campaign, so that gives us 30 minutes of 0G. And if we have 3 campaigns per year, that is equivalent to 1 orbit around the Earth, equivalent to a space lab type of orbit around the Earth, or the type of microgravity time we have on board the International Space Station.
So you see that, of course, Parabolic Flight 0G is very interesting, and you use also several little videos there also showing the fish flying in this bubble of air in the water. Well, I can reassure you, of course, the fish enjoy very much its experience. We brought him back, and he stayed. He lived another few years, and eventually died of old age, but perfectly fine. You see also there was one part where you see one of the operator was upside down, and I put upside down between quotes because there's no up, there's no down in microgravity. What gives you the feeling of up and down is the force of gravity pulling you down. You're standing on the floor because the gravity pulls you down. In 0G, when you're in free fall, when you're in microgravity, there's no force acting on you, pulling you down anymore. Well, yes, of course, gravity is still there, but in the vehicle in which you are falling at the same speed and the same velocity, the same acceleration than the vehicle in which you are, where you are. So you do not feel anymore the gravity. Gravity is still there, of course, because it's the reason, the cause of the free fall. What is interesting also with the aircraft parabolic flight, we can do not only 0G, but we can do also Moon and Mars gravity. And this is very, very interesting because it opens new possibility for research, for engineers, for scientists, for medical doctors, and so on, to conduct research on short duration of periods of reduced gravity, equivalent to Moon or Mars gravity, to try to understand how the body reacts and how the body functions in this reduced gravity. So you see here the various parameters. The injection angle is 47 degrees for 0G. For Moon and Mars parabola, we do flatter parabola, flatter between cores, of course, and there's no longer parabola, obviously. It's a trajectory which is a bit flatter, a bit more elongate. You see also the duration is slightly different. It's about 20 seconds for 0G, 25 seconds for Moon parabola or Moon trajectory, and about 30 seconds, 22 seconds for Mars trajectory. So what does it give? Well, here a few examples, very shortly, of course. You see here we have on the top part, the left part here, you see a drop of water, a drop of liquid, basically. Actually, the fluids, liquids react immediately to the onset of 0G. And you see it floating freely in front of you, assuming a spherical shape, which could be slightly disturbed. But the sphere is the perfect shape of a fluid abandoned to itself in free fall in microgravity. You see at the bottom part here on the left side, three layers, let's say three rows and 4 columns. Each column corresponds to a different gravity level. The most leftward is 1G, so we are on Earth typically. The second one, 0.38 G, so that's Mars, 0.16 equivalent to the Moon, and then the 0G, like you would have in free fall in space, for example. And this little experiment, you have a hotspot which is placed at the bottom part here, bottom surface of this container containing liquid water, basically. And this hotspot would create bubble, gas bubble, so vapor of water bubble. And this bubble in 1G, you see that it immediately going up due to normal convection, so they leave the hotspot quite rapidly. A little bit less rapidly in Mars gravity here, and even slower in Moon gravity. And here in 0G, you see that they don't leave at all, or unless they are slightly disturbed. And this is interesting to see, to observe this kind of behavior, because it teaches you also how these physical systems react in space. And the other row corresponds to temperature measurement and heat flux measurement as well. So that was taken with a thermal camera. A lot of experiments are done also on human physiology. This is here on top in the middle part. This is one of my friends, Professor Jean-Louis Tonard, who's doing an experiment on prehension and kinetics. And I was subject for this experiment, and you had to move an object up and down. And this object was actually filled with electronics and captor and sensor just to measure the very slight little difference in force that you exert between the two things, the thumb and the index finger, when you actually have to grab this little object. And then if you do a movement up and down, well, the force that you would apply would slightly decrease on the downward motion because you go along with the gravity on Earth, I'm talking. And then slightly more, you pinch a little bit more when you go up. Now you repeat this experiment on board the plane in Parabolic Flight. There you have period of 1G, 2G, and 0G. Of course, 2G you would pinch a little bit stronger because the weight is double. But in 0G, you do not need to hold the object because the object would simply go along by itself. So what you do, you would eventually decrease your pinching force, just accompany the object, grab it back there, pinch it, and then show it the new movement. So pushing it downward and then grab it again at the bottom and so on. And then from there on, you can deduce a lot of information about how the brain is processing this new environment for different kinds of subjects. Another experiment here at the bottom right, where you see, well, actually you have to turn this image like that. This is ESA astronaut Alexander Gerst, German astronaut Alexander Gerst, was testing a new kind of running treadmill, basically, that we wanted to test. But the problem was that we could not put it normally vertically on the floor of the aircraft because the underfloor of this treadmill was too large, so the aircraft was not high enough. So we had the idea of tilting the thing 90 degrees, and you see the red part there, which is basically some sort of a support for the astronaut or for the subject, in this case, to lie on it during the 0G, during the 1G and the 2G phase. And once you enter into the 0G, to step on the treadmill and start to run toward the ceiling in 0G. And at the end, of course, the 0G, you come back on the map. So parabolic flights are very useful to do all this kind of research. Very interesting. You can do a lot of experiment. But we did
An even
also
more realistic
astronaut training.
introduction to weightlessness came last May, when the team took part in a parabolic flight in Bordeaux, France. Inside a modified Airbus 300, a special flight path gave them up to 22 seconds of weightlessness at a time. They used this unique opportunity to train on equipment, carry out experiments, and to just get a feel for microgravity, something that an ISS crew lives with 24 hours a day.
So this was actually the new crew of astronauts, the new group of astronauts that ESA selected in 2008, 2009, around there. And I was one of the instructors on this flight, so I had a chance to accompany them. Very interesting flight that we did also with them. So you see that not only we can do research, we can also train astronauts for future flight on the ISS. But that's not all. We can do also use this aircraft to do some research, not only research, but to allow general public to discover the 0G. Here you see a moon parabola. So moon parabola, so it's only about 1/6 of our own weight, and there the exercise that the participants have to hold each other by pair and then try to lift them to feel the difference of the weight of one person to another. So this parabola lasts for about 25 seconds, and then it's time to lie down again. Now we have a 0G parabola, and look what happened to this lady there at the back. She is a bit lost here, and she did not know exactly where to go. They had a very simple task. We asked them to go from one side to another of the aircraft, just to float freely from one side to the other of the aircraft. And you see how difficult it can get. So at the end of the parabola, okay, everybody again lie down here in 2G, and then again we have another parabola where I ask them again to move. And you see the same lady here is gone completely lost until eventually she grabbed something, and then we could help her to bring back. So just to show you that motion in 0G and working in 0G is extremely difficult if you do not know how to do it. When you do that for the first time, you fly in 0G for the first time, you are completely lost because you lose absolutely your normal reference, which are always earth-bound. We all were born and lived in a environment of 1G, constant environment of 1G. And then suddenly we switch this environment from 1G to 0G. Your brain, your feeling, your guts, everything is lost. You do not know how to work and function anymore. And you have to learn to do that. So this is quite an experience, also a learning process, learning curve to go through that. And in the future, well, we will have also the company where I work now, Blue Abyss. We would propose also a new approach for astronaut training. And then we would have three important parts, I would say. The first one would be a pool that you see here that we will use for training divers, but also training an astronaut, do EVA training in the water. We would have also parabolic flight, as I just explained, where we would train also the astronaut not only to do movement and motion in 0G, but also do a bit more using specialized tools and learn how to manipulate these tools and the environment into a 0G environment, or Moon G and Mars G as well, to prepare for future mission on the Moon and Mars. Then we would have a centrifuge also, basically, to do research on the human physiology at high G. We would have also a very important part on STEM and education, and we hope that we would have astronaut, not only astronaut, but also general public and citizen astronaut who would fly in space with suborbital flight to start first with suborbital flight and then later on the ISS. So today this is our home, and we should be very happy and pleased to live on this beautiful planet. But very soon in the future, these will be our homes tomorrow, the Moon and Mars, and after that beyond, of course. So thank you very much again for your attention. If you have any question, I'm sure that we would have time to discuss in the little Q&A session now. Thank you again, and I will come back to the main stage here. Thanks for the opportunity of talking also.